Welcome back to my channel. Today's problem is taken from the British Mathematical Olympiad 1997. For positive integers n, the sequence a sub 1, a sub 2, a sub 3 up to a sub n is defined by a sub 1 equals 1, a sub n equals n plus 1 over n minus 1 times the sum a sub 1 plus a sub 2 plus a sub 3 up to a sub n minus 1 for n greater than 1. Determine the value of a sub 1997. There are many ways by which you can approach this problem. One of those is by deriving an explicit formula for the sequence, and that is exactly what we're going to do now. To do this, we can simplify the given formula for a sub n. Let me just copy this first. So we have a sub n equals n plus 1 over n minus 1 times the sum a sub 1 plus a sub 2 plus a sub 3 up to a sub n minus 1. But the term before a sub n minus 1, or that comes first before a sub n minus 1, is a sub n minus 2. So I'll just write it a sub n minus 2 plus a sub n minus 1. Now, I'm going to come up with a formula for a sub n minus 1 using this definition. So by definition, a sub n minus 1 is equal to n minus 1 plus 1 over n minus 1 minus 1 times a sum of several terms up to a sub n minus 2. Okay, now we have here n over n minus 2 times a sub 1 plus a sub 2 plus a sub 3 up to a sub n minus 2. You can derive this by replacing n in the first equation by n minus 1. Okay, now I'm going to multiply both sides of this equation by n minus 2 over n. So we have n minus 2 over n times a sub n minus 1, which is equal to a sub 1 plus a sub 2 plus a sub 3 up to a sub n minus 2. Now notice that these terms, or this sum, can be replaced by n minus 2 over n times a sub n minus 1. Okay, so a sub n is equal to n plus 1 over n minus 1 times n minus 2 over n times a sub n minus 1 plus, take note, we still have here a sub n minus 1. So we have here plus a sub n minus 1. Okay, now I'm going to distribute n plus 1 over n minus 1 and then factor out a sub n minus 1. Okay, so we have a sub n equals n plus 1 times n minus 2 over n times n minus 1 plus n plus 1 over n minus 1 times a sub n minus 1. Alright, now let's simplify the terms inside. So you have a sub n equals so the denominator is n times n minus 1. The numerator is n squared minus n minus 2. This one, n plus 1 over n minus 1, is the same as n times n plus 1 over n times n minus 1. Okay, so a sub n is equal to n squared minus n minus 2 plus n squared plus n, all divided by n times n minus 1. And then this fraction multiplied to a sub n minus 1. Now, we can cancel negative n and plus n, and then come up with 2n squared minus 2 all divided by n times n minus 1. This fraction multiplied to a sub n minus 1. Now we can factor the numerator to get 2 times n plus 1 times n minus 1, and then we have over n times n minus 1 times a sub n minus 1. Now we can cancel n minus 1 and have the formula a sub n equals 2 times n plus 1 over n times a sub n minus 1. Now we can use this to come up with an explicit formula for a sub n, because this one is much simpler than the original formula. Okay, so before we come up with an explicit formula, I'll come up first with a formula for a sub n minus 2 and a sub n minus 3, because we can use those to derive the explicit formula I'm talking about. So, what is a sub n minus 1? A sub n minus 1, using this formula, can be obtained by replacing n by n minus 1. So, a sub n minus 1 is 2 times n minus 1 plus 1 over n minus 1 times a sub n minus 2. So, I can just have n on top and then n minus 1 as the denominator times a sub n minus 2. Now let's derive a similar equation for a sub n minus 2. So just replace n here with or by n minus 2. So we have a sub n minus 2 equals 2 times n minus 2 plus 1. So that's n minus 1. And then over n minus 2 times a sub n minus 3. Okay, now I'm going to substitute the equivalent of a sub n minus 1 here. So we have a sub n is equal to 2 times n plus 1 over n. A sub n minus 1 is equal to 2n over n minus 1 times a sub n minus 2. Now we know that a sub n minus 2 is equal to 2 times n minus 1 over n minus 2 times a sub n minus 3. So I can just replace a sub n minus 2 in this equation. So we have 2 times n plus 1 over n times 2n over n minus 1 times 2 times n minus 1 over n minus 2 times a sub n minus 3. Now, notice that there is actually a pattern in the numerator and in the denominator. So there is a decreasing factor. Take note, we have n plus 1 followed by n minus 1. Same thing with the denominator, we have n minus 1, and n minus 2. So if you continue this process, a sub n is equal to 2 times n plus 1 times 2n over n minus 1 times 2 times n minus 1 over n minus 2 times, so we will have here 2 times 3 over 2 times a sub 1. Okay, now Notice that we can cancel some factors. We have to cancel n minus 1, n minus 2, up to 3. Okay, now we need to know how many factors of 2 there are. Now, how can we do this? Notice that in the denominator, we have the numbers 2 up to n. So, how many numbers are there? There are n minus 1 of these numbers. In other words, there are also n minus 1 factors of 2 in the numerator. So, a sub n is equal to 2 raised to n minus 1 times n plus 1 divided by 2. Take note, we did not cancel the 2 here, so we still have a denominator of 2. Now, we can simplify this further. We will have 2 raised to n minus 2 times n plus 1. So now we have the explicit formula for a sub n, and then we can now solve for a sub 1997. Take note, by the way, that by definition a sub 1 is 1. Okay, that's why here a sub 1 is gone. Okay, so I'll just put it here. So we have here a sub 1, but a sub 1 is 1, where a sub 1 is equal to 1. That's why we have this formula. Now we can just substitute n equals 1997. So we have 2 raised to 1997 minus 2 times 1997 plus 1. So we have, I'll just write 1998 first times 2 raised to 1995. Okay, so this is now the value of a sub 1997.